Lifeline. Okay. That'll work. All right. Let's see. So one thing is, let me ask you this. What do you think about, I used to give an example of like a cat versus a dog, and then somebody told me there was some stupid cartoon a while back that was like a cat dog monster. Remember that from when you were little kids? Yeah. Cat dog, yeah. We won't get into the biology of this creature. But can you tell me, like, Jack and an 8? Is there any card that could be both? Could you have a card that is a Jack and an 8? No. Could you have a card that's a Jack and a club? Yes. Yeah, the Jack of clubs. So Jacks and 8s are examples of two events that are mutually exclusive. Now think about the words involved there. So mutually exclusive, right? So I also used to do man and woman, but sometimes there are people transitioning, so they're in between somewhere. So I had this come up in class once when I said men and women, and we had a big discussion. I thought, let me not do that ever again. So rocks and ice cream. Obviously, there's nothing that is both. What about?
There's rocks.
Oh, but are they rocks? Let's stay focused. Yeah, we're not all out there going, this rock is yummy. Let me sell this. What about? There's an example in the book that says like male students and future nurses. Are those groups mutually exclusive? No, because there's students who are men who are studying to become nurse, right? So stuff like that, that kind of problem. How do you answer that kind of problem? How do you think about that kind of problem? If they say, are these two mutually exclusive? Can you imagine anything that is a member of both? If you can, it's not mutually exclusive, right? They don't mutually exclude each other, like salamander and a parakeet would. There are no salamander parakeet cartoons yet, so they mutually exclude each other. If you are one, you cannot also be the other one. Whereas female Republicans exist. So you can be a female and you can be a Republican. So those are not mutually exclusive. They don't mutually exclude each other. How are we doing? Yeah. So that phrase actually makes sense. It doesn't happen all the time in math, but it does here. So mutually exclusive means they have no overlap. Now here's something to think about. What does that mean then if A and B are mutually exclusive? Then what's the probability of A and B? Careful now. Not probably A or B. Even then, it's not guaranteed. So give me an example. What we just say was not mutually exclusive. I mean, that was mutually exclusive. Like rocks and ice cream, right? Or we have some people out there looking rocks, but we're not going to make fun of them. So what's the probability of getting ice cream that is also a rock? 0. If they are mutually exclusive, there is no overlap. There could be none that is in both. Cool? All right, so that's that. Some books make it, I can't remember this one does, but they make a big deal like it's a brand new equation. But remember, the probability of A or B, like you guys told me, it's basically add, but sometimes you're going to have to subtract off anything that's both, right? Like jacks plus clubs minus the jack of clubs to make sure you don't double count. Well, if they're mutually exclusive, what happens to this equation? It's the same, except this now is 0. So it's not a new equation, it's just that's the one time you can just add them together. That was.
Can you use a different color pen?
Yes,
it's really
I can.
hard to see.
I always forget that red is not easy to see for some people. So that's mutually exclusive. That's not too bad. Oh, what's up? Is this
You're filming the ceiling.
the ceiling?
In the corner.
Oh, poor little dude. Yeah, I just forgot my little
stand.
This in front of.
Yeah, cool. Thank you. I'm just going to steal all your stuff. Okay. That's going to have to work. All right.
Independent events. I don't want to spend a ton of time here, but this word, this idea keeps coming up every now and again later in statistics. The other day we did a problem like, let's probably getting a king given it's a club. You were here, do you remember doing that?
It's 1 out of 14.
Yeah, because what the bottom now becomes 13. Why?
The bottom becomes a given.
Because that's how many chances you have, right? If you know it's a club, there's only 13 cards it could be. So whenever it's a given, it's pretty much always going to reduce the bottom. There are fewer things it could be then, right? So given that it's a club, that means there's only 13 cards it could be. How many kings out of those 13 clubs? One. Did that change? What was the probability of king by itself? 4 if it's 2, which is? So it didn't change, right? So even though I tell you a club, like if I took a card and say, okay, this is a club, did it change the probability that it was a king? Did it change? So one thing happened and the other one didn't care. You guys with me on that? If I say it's a club, did the probability of being a king then change? What was it before 1/13? What is it now? 1/13. So would you say that they're independent or dependent if one happens and the other one doesn't care? Independent. Doesn't that just make sense? Yeah. Dependent means if you do something, I care, right? I'm dependent on you. Don't go that way. You're gonna fall. You know. Independent is you do whatever that you happen. That's nice for you. That's great. I'm still me. So, right? So, okay. So something that would be. So this would be king and clubs are independent events. So we did something the other day that were dependent events, where the probability actually changed. Remember, was that smart question to ask? If you think it's a king I picked, the smart question to ask would be, is it a face card, right? Remember, if we had probability of a king given it's a face card, there were how many face cards? 12, right? 3 face cards for every 4 suits. For each 4 suits, that's 12, and there's still all 4 kings. So was the probability of a king, is that equal to the probability of king given face card? Are they equal? What was the probability of king by itself? 1/13. What's the probability of king given that it's a face card? It's not the same, right? So this is not equal to it. So this will be dependent. Let me give you another example. I want to make sure you guys understand. Because people take it to extremes. If I told you that somebody just drove up riding a Harley Davidson motorcycle, would the probability that it's a man change? So I say, oh, there's somebody coming. What's the chance it's a dude? 50-50 is my best guess, right? But say, oh, somebody just drove up on a motorcycle. Now, I know there are women that drive motorcycles, but be realistic here. What would the probability that it's a man, would it go up or down? It would go up, because there are more men who drive motorcycles, right? So it's all about probabilities here. Are they dependent then? Men driving a motorcycle. Are those dependent? If I told you that one happened, does it change the probability that the other one? Remind me what you just said. If I tell you, oh, there's somebody coming up on a motorcycle, so given that they're on a motorcycle, is the probability as a man change? Yes. Yes. So let me think of something else here. So let's say I'm going to move to Minnesota, right? Should I buy a heavier jacket than what I own now? Yes. So given that I'm going to be in Minnesota, I'm trying to get the probability that it's going to be cold has changed, right? It's dependent on where you are. The probability of it being cold changes. Dependent on what I see coming up. It's going to change the probability of if it's a man or a woman, right? Somebody's coming up on a bike. I see somebody coming up on a bike. What's the probability that they're over 50? Has that changed now?
Yes.
Yes, it's gone way down, right? I'm not saying that there are no 50-year-old people that are over that ride bicycles. What's the probability? Has that changed?
Yes.
Yeah. So then riding a bike and being over 50 are dependent events. If I know that one happens, it changes the probability that the other one is going to happen. Right? Do you guys get that idea? Okay. All right. That's actually really important. Oh, yeah, I can see what you mean. That's definitely easier to see. For later, that idea of independence is going to come up. So the main thing to realize there is how did we do, where's my eraser there? High-tech eraser. How do we do this problem? If I took two cards with replacement, what's the probability I get a king and then a king? So there's two cards, right? And here's what I like. You're going to see a lot of problems like that. I pick 20 people. What's the probability I pick 2 left-handers? Or if I pick 80 cars, what's the probability that 3 of them are running out or have no gas? Or, that kind of problem I'm going to see a lot. Yeah, right now, who knows? But I'm picking 2 things. So I like thinking of like a hangman game. There are 2 spots for me to fill. The first one I want it to be what? King. Oh, so go ahead.
Well, just like you said, okay, if there's 20 people and then what's the probability of 2 of them being left-handed? Don't you have to know if there's any people left-handed in that group first?
You have to know the probability that there's a left-hander, yes. Cool.
Okay.
Right? So we're actually going to do that problem next.
Okay.
Yeah. But here I know the probability of getting a king. So what's the first card I want it to be a king. So what's the probability it's a king? 4 out of 52, yeah, or 1 out of 13. And the other one's a king. So times, now what's probably the other one's a king? I put it back in, don't I? So does the second one change? No, so it's still 4 out of 52. So these are independent events if I do it with replacement, right? And you can see it. Does the probability change given that I picked a king? Does this care? No. Of course it doesn't care because I put that first one back in. And that's where we got the 1 out of 169 or whatever the hell that was. If I do this without replacement, what happens? First one is still 4 out of 52. Then I throw it away. 3 out of 51. So what is that probability specifically? Can somebody tell me in English what that probability represents? What is that probability? It's probably I get another king. So say it a different way. It's probably I get a king given that I already got a king. Right? Isn't it? That's the second one. Why did it change? Because I got a king already and I threw it away. So that's probably I get a king given that I already got a king. That's why I had to go down. Why didn't that one change? Because I put the first one back in. So would this be independent or dependent in this case?
Dependent.
Dependent, totally. Because it depends on what I got first. Right? Okay, that's the idea here. I love it. So here's the test for independence. This definitely sounds like a note. The test for independence. This is not, do you have a patriotic anthem? This is testing 2 events to see if they're independent. If the probability of A given B is still the probability of A. So what does that really say? B happened, given that I'm in Minnesota. The probability that